Dear students, I would like to discuss with you the cumulant generating function of the normal distribution and its utilization for finding the cumulants. So, what is the cumulant generating function? As you already know, for any distribution for which the MGF exists, the CGF, capital K of t, is the natural logarithm of the MGF. Yani, capital K of t is equal to log natural of the expected value of e raised to tx. Now, students, for the normal distribution, having mean equal to mu and variance equal to sigma square, the cumulant generating function comes out to be capital K of t is equal to mu t plus sigma square t square over 2. It is very obvious. अभी मैंने आपसे कहा कि it is the log natural log of the MGF. तो well known है, everybody knows it, that the MGF of the normal distribution is e raised to mu t plus half sigma square t square. तो जब आप उसका natural log लेंगे तो जाहिर है कि जो चीज़ e raised to पावर में जो चीज़ आई हुई है, that will come down and it will simply become mu t plus half sigma square t square. All right, so this is the CGF of the normal distribution. Now, in order to find the cumulants, we will need to take the derivatives of this CGF one by one. Yani, first derivative and second derivative and third derivative. So let's do it. The first derivative of the CGF, capital K dash t, is d by dt of mu t plus sigma square t square over 2. So that is equal to mu plus sigma square into t. एक दो स्टेप्स हैं इंतहाई सिंपल जो आप खुद ही कर सकते हैं. अब ये जो आपका आया है, that's your first derivative. Now for the second derivative, obviously capital K double dash t is d by dt of capital K dash t. So it is d by dt of mu plus sigma square t. तो अब इसका derivative क्या आएगा? Obviously d by dt of mu is equal to 0 and d by dt of sigma square t is equal to sigma square. So 0 plus sigma square is equal to sigma square. Third derivative भी ले लेते हैं. Now, capital K triple dash t is equal to d by dt of capital K double dash t. So that is d by dt of sigma square. अभी हमने निकाला. And then what is d by dt of sigma square? Sigma square is a constant. So obviously the derivative is equal to 0. तो अब आप नोट करें कि third derivative CGF का जो है, that has come out to be equal to 0. Then, my dear students, is it not obvious that the fourth, fifth, sixth, and all the higher derivatives, they will all be equal to 0? जब third ही 0 आ गया है, तो अब आगे 0 का derivative जब लेंगे, तो जाहिर है कि that is also equal to 0. तो अब ये जो कुछ हमने कर लिया, उसके बाद how do we find the first cumulant? Well, it is the value of the first derivative at t equal to 0. So we can write it as capital K dash 0. And what is it equal to? Mu plus sigma square t जो है, उसके अंदर t को 0 put करना है. So it comes out to be equal to mu plus sigma square into 0, यानी mu plus 0, यानी mu. So note करें कि जो first cumulant है of the normal distribution, that is equal to mu. इसी तरह for the second cumulant, जो second derivative निकाला था, उसके अंदर t की वैल्यू को 0 रखना है. लेकिन आपको याद है अभी 1 मिनट पहले या 2 मिनट पहले हम कह चुके हैं कि सेकेंड डेरिवेटिव कैपिटल के डबल डैश टी इज इक्वल टू सिग्मा स्क्वायर. तो स्टूडेंट्स जब इस एक्सप्रेशन के अंदर टी एग्जिस्ट ही नहीं करता तो फिर हम 0 तो नहीं उसको रख सकते ना. जब 0 से सिर्फ टी जहाँ पे हो वहाँ पे उसकी जगह 0 रख देंगे. तो देन व्हाट इज इट इक्वल टू? वेल, इट रिमेन्स एज इट इज. Capital K double dash 0 is equal to sigma square. Yani second cumulant of the normal distribution is equal to sigma square. इसके बाद third की बात कर लीजिए. Third cumulant will be the value of the third derivative at t equal to 0. लेकिन अभी थोड़ी देर पहले हम कह चुके हैं कि third derivative itself is equal to 0. तो उसको वहां पे टी तो है ही नहीं, तो वो जो है वही हमें लिखना है. सो देयरफॉर कैपिटल के ट्रिपल डैश 0 is equal to 0. And similarly, all the higher cumulants will also be 0. अब ये सारी डेरिवेशंस करने के बाद, in a nutshell, what do we have? We can say that the cumulants of the normal distribution, n mu sigma square, जो normal distribution है, the cumulants are as follows. The first cumulant is equal to mu, that is the mean, median, or the mode of the distribution. The second cumulant is equal to sigma square, that is the variance of the distribution. And the third, fourth, and higher moments, K3, K4, and so on, they are all equal to 0.